We're on lesson 7 of chapter 10, which is combinations. First, we're going to use a table to find combinations. Then we'll use a tree to find combinations. First, what is a combination? Well, a combination is a grouping of objects or events in which the order of the events does not matter. Let's give you an example here. Sarah wants to display 2 pairs of jeans in her department store. She has 3 colors of jeans, blue, white, and green. How many possible combinations of jeans could she show? So she wants to have 2 pairs of jeans, and for these ones it doesn't matter which order they go in. You could have a blue one on the left and a white one on the right, or a white one on the left and a blue one on the right. That does not matter. Here below us we have the tree method to solve this one. We can make the blue pair of jeans color 1, and then with the blue pair we could have the white pair as a combination, or the green pair as a combination. We could have the white pair as color 1. If we have blue as color 2, notice we've already done blue and white before, so that wouldn't be a combination. That's why there's no check mark there. But we haven't done white and green before. See, that wasn't a combination anywhere here. And if we have green as color 1, we've already done green and blue over here, and we've already done green and white over here, so neither of these we can add to it. So I see a total of 3 combinations here from this tree. So if she has 3 colors of jeans and wants to display 2 different pairs, she could do it in 3 different ways. Now we can use a table to find combinations. It says Mrs. Logan's students have to read any 2 of the following books. 1. Treasure Island. 2. Call of the Wild. 3. A Christmas Carol. 4. Tom Sawyer. Or 5. Tuck Everlasting. How many possible combinations of books could the students choose? So when you use a table like this, you notice a table has columns and rows. We can list the number of books on the columns and also the books on the rows and look for combinations. So we have book 1, 2, 3, 4, and 5. And in the rows we have 1, 2, 3, 4, and 5. So as we do our pairings here, we have 1 and 1. Well, you can't pick 1 and 1, so that one's out. As is 2 and 2. So is 3 and 3. You can't do that. And I'm going to go right down the line. 4 and 4 you can't combine. And 5 and 5 you can't combine. So now let's use the rows. We have book 1 and book 2. That's a combination. 1 and 3, 1 and 4, 1 and 5. Now we have book 2 and book 1, book 2 and book 3, book 2 and book 4, book 2 and book 5. Now we have 3 and 1, 3 and 2, 3 and 4, and 3 and 5. We have 4 and 1, 4 and 2, 4 and 3, and 4 and 5. Then we have 5 and 1, 5 and 2, 5 and 3, and 5 and 4. And you're going to notice something here. On the opposite sides of these X's here, we have doubles. We have 1 and 2 here. On this opposite corner, we have 2 and 1. 1 and 3, and 3 and 1. Remember, for combinations, order does not matter. If you read 1 then 2 and then 2 then 1, you're reading the 2 same books. So since this is a double, we can cross that out. 1 and 3 and 3 and 1, that's also a double. And you're going to notice 2, 3, 3, 2, 1, 4, 4, 1. Everything on this side of the X's can be crossed out because they have a partner. So that leaves us with just these combinations here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 total combinations. Here we have this one. Christie's Diner offers customers a choice of 4 side dishes with each order. 1 carrots, 2 corn, 3 French fries, or 4 mashed potatoes. How many different combinations of 3 side dishes can Kareem choose? So here you see that Kareem could choose 3 side dishes, and that changes things up quite a bit. Here we only had to choose 2, so you can use a table to find just combinations of 2. Well, how could you use a table to find combinations of 3? The answer is you can't. You have to use 2 tables. So first we're going to find combinations of 2. Then once we have these combinations of 2, we'll use a different table to find the combinations of 3. This will become clear as we go along. So we have 1, 2, 3, and 4. And 1, 2, 3, and 4. So we know that 1 and 1, 2 and 2, 3 and 3, and 4 and 4 aren't combinations. We have 1 and 2, 1 and 3, 1 and 4, 2 and 1, 2 and 3, 2 and 4, 3 and 1, 3 and 2, and 3 and 4, and then 4 and 1, 4, 2, and 4, 3. Just like in this last table, we have doubles on both sides of the x's here, so I can cross off all these ones because they have a matching one on the other side. And that leaves us with 1, 2, 3, 4, 5, 6 combinations. So what I can do is I can use a second table. I have 6 rows for my 6 combinations. Then I have 4 columns for the 4 types of ones I can add to make it a third. So let's list off our combinations of 2. The first one is 1, 2. Then we have 1, 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4. Now we have our 4 sides that we can list across on the top, 1, 2, 3, and 4. Now we can add whatever ones aren't repeated already. So we have 1, 2, and 1. We can't do that because we already have 1. We can't do 1, 2, and 2. We can do 1, 2, and 3. And we can also do 1, 2, and 4. We can't do 1, 3, 1 because we already have a 1 there. We could do 1, 3, 2, but because we have 1, 2, 3 here, we don't need that either. We can't do 1, 3, 3 because that wouldn't work. We could do 1, 3, and 4 though. That hasn't been used yet. Now let's look at this. 1, 4, 1. Nope. 1, 4, 2. Well, we already have 1, 2, and 4. 1, 4, 3. Well, we already have 1, 3, and 4. And 1, 4, 4 I can't do. 2, 3, 1. I already have 1, 2, 3. 2, 3, 2 has a repeat of 2. 2, 3, 3 has a repeat of 3. 2, 3, 4. I do not have a 2, 3, 4 yet, so let's go with that. 2, 4, 1. I already have 1, 2, 4. 2, 4, 2 is a repeat of 2. 2, 4, 3. We already have 2, 3, 4. And 2, 4, 4 is a repeat of 4. 3, 4, 1. I already have 1, 3, 4. 3, 4, 2. I already have 2, 3, 4. 3, 4, 3 is a repeat of 3. And 3, 4, 4 is a repeat of 4. So we've made our second table. So now I have only found 1, 2, 3, 4 combinations of 3 that aren't repeats. So that means our answer would be 4 combinations. Now let's use a tree to find combinations. So it says, as a caterer, Charlie offers 4 vegetable choices: broccoli, squash, peas, and carrots. Each person can choose 2 vegetables. How many different combinations of 2 vegetables can a person choose? So this is very similar to that first one where we use a table where we start with 1 as color 1 and 1 as color 2. Kind of do that same thing with vegetables here. This is vegetable 1. What kind of vegetable 2s could we have? Well, we can't do broccoli with broccoli. We could do broccoli with squash. We could do broccoli with peas. And we could do broccoli with carrots. So far we have 3 different combinations. So now let's try with squash. We could try squash with broccoli, but we already have that here. So I'm going to skip the broccoli, or I'm just going to put an X over that. We can't do squash with squash. We could do squash with peas, though. We haven't done that yet. And we haven't done squash with carrots. So that gives us 2 more. Now we have peas. So we'll have 3 branches again. Peas and broccoli. Well, we already had peas and broccoli here. So not that one. Peas and squash. Oh, we already had peas and squash here, so we'll cross that one out. How about peas and carrots? I have not seen any peas and carrots yet, so that would be a combination. Now we have just carrots. And before I do this one, let's see if we've noticed a pattern so far. For broccoli, we had 3 combinations that hadn't been used. For squash, we had 2. For peas, we had 1. How many combinations do you think we're going to have for carrots? Let's find out. Carrots and broccoli. Well, we already had carrots and broccoli, so not that one. Carrots and squash. Well, we already had carrots and squash, so not that one. Carrots and peas. Well, we already had carrots and peas, so not that one, and we clearly can't do carrots and carrots. So how many combinations did we have with carrots? Well, none, because we used them all up already. See, they were here, here, and here. So how many total combinations does that give us? We have 3 here, 2 here, and 1 here. That adds up to 6 combinations.